What are the most outrageous things that you could accuse a pilot or an airline of doing? Well, whatever you choose, I can almost guarantee you that it will appear in this story. It is a horrifying account of how every possible safety barrier can be breached if training, CRM, maintenance, and just general common sense is not used. Stay tuned. This story will focus on what happened to Aeroflot North Flight 821, but to fully understand and to appreciate its gravity, you first need to know a little bit of background on both the pilots and the airline involved. Aeroflot North was originally called Archangel's United Aviation Squadron, and it was formed in the then Soviet Union back in 1963. It continued to exist as a mainly regional domestic operator until in 2004 the then Russian flag carrier Aeroflot bought 51% of its stock and renamed it Aeroflot North, turning it into a purely regional Aeroflot subsidiary. This marked the beginning of a very strong company expansion, and the management quickly realized that they would need to start buying Western-built aircraft in order to keep growing. The aircraft they chose to go with was the Boeing 737-500, which was perfect in both size and relative cost for the planned expansion. 12 737s were bought, and in 2006 the Russian aviation authorities allowed the company to start operating them. But it seems like the authorities didn't look too closely into how these aircraft were going to be implemented into the existing fleet or how the training of Aeroflot North's pilots on these aircraft was going to be done. Because prior to the arrival of the 737, the fleet of Aeroflot North had consisted of only Soviet-manufactured aircraft like the Tupolev 154, the Tupolev 134, Antonov 24 and the Antonov 26. What all of those aircraft had in common was that they required a 3 or sometimes 4-man flight crew, where a flight engineer dealt with the engines and sometimes a navigator did the en route navigation. This meant that the pilots who were now going to operate the more modern 2-pilot cockpit of the Boeing 737 had to undergo not just a major change in technical system knowledge, but also a crew resource management and flying philosophy change, much bigger than what most people realized at the time. On top of that, all of the manuals and system descriptions of the 737 was only available in English, a language that these Russian pilots had only a very rudimentary understanding of. Now, a fully operational knowledge of English was of course required for any pilot operating in international airspace, but these pilots had only flown domestically in Russia up until this point and had therefore never really needed to learn English properly. The pilots who were eventually going to operate Flight 821 were, on top of this, also quite new in their roles. The captain was 35 years old and had a total flying experience of only 3,900 hours, 2,800 of which had been flown on the Soviet-type Tupolev 134 and the Antonov 2. He had only operated as a first officer on those types and had still been upgraded to a captain on the Boeing 737 after having flown only 713 hours on this completely new type. This meant that he was both new on the type and as a captain when this accident happened. His type rating training on the 737 had been done in the US, but for some reason the training paperwork hadn't been saved, so we don't really know how well he did on that course. But what we do know is that there were also several irregularities in his subsequent line training and check-in records, as it seems like Aeroflot North didn't really follow their own state-approved training programs very carefully. Before reporting for Flight 821, the captain had rested for about 15 hours, which was more than the stipulated minimum, but during the 3 previous days he had been working long night flights with several serious breaches of minimum rest regulations, leading to possible accumulative fatigue. As an example, on one of these occasions he had rested only 6 hours instead of the minimum 12. His English knowledge was reported to be at an acceptable level, equivalent to ICAO level 2 out of 6, which wouldn't be high enough to fly internationally, but still significantly better than the level of his colleague, which we'll get to next. The first officer was 43 years old and had a total flight time of 8,900 hours, which was actually more than the captain had, but a full 7,000 of those hours had been flown on the old Soviet propeller-driven Antonov 2. He had then flown 1,600 hours on the Tupolev 134 before transitioning over to the Boeing 737, which he, at the time of the flight, only had 236 hours on. He had completed his typewriting training for the 737 in a training center in St. Petersburg, and the record showed that he had been struggling quite a bit during that course, specifically with the use of English. This had caused him trouble with following the standard operating procedures and understanding the manuals and systems, but also, crucially for this story, he had shown issues with handling the aircraft after engine failures or with significant amounts of asymmetric thrust. You see, both pilots had been flying Soviet aircraft before, who had either only one engine, like the Antonov 2, or engines spaced very close together, like the Tupolev 134. If the engines are spaced close together, the effect of thrust asymmetry, like in the case of an engine failure or malfunction, will be much less severe due to the smaller moment arm from the still operating engine. On the Boeing 737, where the engines are hanging below the wings and much further from the center of the aircraft, the pilots would need to counteract this yawing momentum with rudder much more forcefully than these pilots were used to, and the first officer had reportedly struggled a lot with this. To that should also be added that in some cases, pilots coming from Soviet-type aircraft wouldn't even have handled the thrust levels much themselves, as this was normally done by the flight engineer on those types. But the main root of the problems for the first officer was, like I mentioned before, his English language level. He had completed a beginner's course followed by an advanced aviation technical English course just prior to joining the typewriting, but the school who had provided this training to him was later found to lack accreditation and using teachers without any teaching background or verified English language knowledge. It is also worth noting that even though the pilots had gone through recurrent training and check-in after their typewriting was finished, there were no specific training for aircraft upset prevention and recovery anywhere in the airline's syllabi. So that's the story of the pilots, which leads us to the aircraft that they were going to operate on this flight, because it will also play a huge role in what's about to happen. The aircraft's registration was Victor Papa Bravo Kilo Oscar and was registered in Bermuda, which is actually the reason why we have access to this final report in English. It was a Boeing 737-505 with 44,533 hours on the airframe, and it had previously been operated in China for another airline. There were a couple of peculiarities with this aircraft that will all play important roles in this story. First of all, this aircraft had a different type of flight director fitted than most of the other 737s in the Aeroflot North fleet. It didn't have the standard command bars. Instead, it had the older integrated Q or V-bars type, where a V-shaped aircraft symbol is used to follow a magenta V-shaped guide. That guide V has the same shape as the aircraft symbol, and remember that. Here, it's also worth mentioning a fundamental difference between Western-type attitude indicators and Soviet ones. In Western instruments, the aircraft symbol stays still and the horizon moves inside of the instrument, basically simulating the same view that the pilots see when they look outside of their windows. But in Soviet attitude indicators, the horizon stays still and instead the aircraft symbol moves, showing a picture to the pilots as if they were sitting in a level position behind the aircraft, watching it move in relation to the horizon. That's a small but fundamental difference, which makes the transition to flying Western aircraft even trickier for ex-Soviet pilots, especially if the aircraft start getting into extreme attitudes where quick decision-making and situational awareness is key. The other thing about this aircraft which is important to know is that it had a recorded history of problems with its thrust levers. Specifically, the two thrust levers seemed to be trimmed differently in the middle position, so that with the thrust levers next to each other, the right engine would produce significantly more thrust than the left one. This was not the case during maximum or minimum thrust lever angles, which pointed to a problem with the engine trim itself or a faulty temperature probe inside of the right engine. In any case, the way that this would manifest itself was that the autothrottle would stagger the thrust levers, basically moving the left thrust lever up higher than the right one to compensate and equalize the thrust output. But for those of you who have watched my video about the Srivijaya Flight 182 accident, you might also remember that the autothrottle has a system called the Cruise Thrust Split Monitoring System built in. That system will disconnect the autothrottle if there is too much difference between the thrust levers, but only if certain conditions are met. It turns out that that had actually happened multiple times on this aircraft during the days before the accident flight, but instead of looking into the root cause of why the auto throttle had disconnected, the engineering firm who had been contracted to do maintenance for Aeroflot North had simply labeled the auto throttle as inoperative. Now, when maintenance do this, they also have to completely deactivate the system by pulling out the associated circuit breakers, put collars on them, and then mark the auto throttle switch with an inop sticker, kind of like this one. But none of that had been properly done, meaning that the crews had just disregarded the note in the tech log and continued to use the auto throttle system anyway, since that was likely much easier. And that brings us to the night of the accident, but first this. Now, before we continue, let me tell you about something really important: ice hockey. Being Swedish and from Örnsköldsvik, I'm a big hockey fan, and my favorite team, Modo Hockey, has been doing really great this year. Now, obviously, since I live in Spain, I've missed most of their games, but when they started playing finals to qualify for the highest league in Sweden, I just had to watch them. So I paid for the pay-per-view package for the Swedish C More channel, and then I sat down together with my wife Sandra, who, as it turns out, also loves hockey, and switched on the TV as the finals were about to start. And it didn't work. It turns out that C More has geo-restricted access to the game to Swedish IP addresses only, and it didn't matter if I had paid or not, I just couldn't watch it. Luckily though, I had access to the app of today's sponsor, NordVPN, and when I switched that on, chose the server in Sweden, then I just had to update the C More app, and there was the game in all its glory. Now, this is exactly the reason I personally use NordVPN and why I have decided to advertise them. They just work. It's a wonderfully fast, user-friendly and safe VPN that just basically does what it says on the tin. If you travel a lot or like getting a good deal, well then use the link here below, which is nordvpn.com/pilot, right now to start testing their services. It will give you a special deal, giving you 4 extra months for free when you sign a 2-year deal. Hurry, because it's a time-limited deal, and remember that you always have 30 days of money-back guarantee, so you're not really risking anything. But now back to the important stuff. How did Modo do in the finals? Well, they won, of course. Now, let's continue. On the 13th of September 2008, the crew, who consisted of the 2 pilots and 4 cabin crew members, arrived to Moscow Sheremetyevo Airport around 01:30 local time. The first officer arrived first with 3 of the cabin crew, and the captain arrived slightly later with the remaining cabin crew member. They first went through a standard medical examination, which they all cleared, and then proceeded to the crew room to look through the pre-flight documentation. The flight was a normal passenger flight going from Moscow to Perm with 82 passengers booked, and when the pilots looked through the weather and NOTAMs, it looked quite okay. There was some rain and mist forecasted at their destination, but it wasn't bad enough to cause any real concern. They then walked out to stand 22, where the aircraft was parked, and started preparing it for departure. The captain checked the tech log and saw that the auto throttle was marked as inoperative, but he could also see that it hadn't been deactivated, and there were no technical personnel around to ask, so he likely figured it could still be used until it failed again. The other inoperative item in the tech log was the aircraft's TCAS system, but they were allowed to operate without it, so that wasn't a major concern. The first officer was going to be pilot flying, so he started setting up the cockpit as the captain did the exterior inspection. Now, as part of the cockpit setup in the Boeing 737, the inertial reference system needs to be aligned. That's a set of laser gyros and accelerometers that helps keep track of the aircraft's position after an initial position has been entered. Those gyros are prone to drifting, meaning that they will only be really accurate for a short while after they have been aligned, and after that they will need help from other navigation systems to correct them. In more modern aircraft, this is done by the GPSs, but there were no GPS installed on this aircraft, which meant that it would need to rely on updating its position using cross-checking of radio aids along the route, primarily VOR DME stations. The problem, though, was that on this particular route there were no such stations close enough to be used. This would mean that the IRS system, which was the primary system used to updating the aircraft's position on the navigation display, would become increasingly inaccurate as the time went on. And on top of that, the first officer also made a mistake when he inputted their initial coordinates, which meant that already from the start the IRS error was about 1 nautical mile. But the information that we pilots get from the navigation display is only really a backup that makes our lives a little bit easier. During instrument conditions and in phases of flight where navigation accuracy is really important, we always need to verify our position with the help of raw data instruments like the VOR or NDB needles or the ILS pointers. So a map shift, meaning that the navigation display is not fully accurate, should not be a huge problem, but we'll get back to that later. When everyone was ready, the captain made a welcome PA to the passengers, and then the first officer requested pushback. 6 minutes later, at time 0306 local time, the aircraft started taxiing out for takeoff from runway 07 left. There were unfortunately no cockpit voice recordings available for the taxi out phase because the cockpit voice recorder in the aircraft only covered the last 30 minutes of flight. So we don't know how well the standard operating procedures were followed, but we do know that the inoperative auto throttle was activated just prior to departure, even though it really shouldn't have. Now, since the first officer was going to be pilot flying, the procedures stipulate that the captain should have handed over the controls to him after the aircraft had been nicely lined up with the center line. The first officer should then have gently increased the thrust to around 40% N1, let the engine stabilize there, as they might accelerate at different speeds initially, and only after that press the toga buttons and call for takeoff thrust to be set. This is a critical safety procedure to make sure that the start of the takeoff roll is done correctly and to avoid potential loss of control due to asymmetric thrust at low speed. But that's not what happened here. Instead, the captain moved the thrust levers forward during the line-up turn to a 55-degree angle, meaning a thrust of 70.5% N1 on the left engine and 84% on the right, since the engines weren't properly trimmed. So that meant that he handed over the controls to the first officer with a significant thrust asymmetry in the middle of the line-up turn. This caused the first officer to have to give full left rudder initially to line the aircraft with the center line, and then almost full right rudder to keep the center line, as the right engine was now pushing more than the left one was. This unnecessary increase in workload and complexity meant that the toga buttons were never pushed, and the correct takeoff thrust was therefore not set either. This in turn caused a slower than normal initial acceleration during the first 20 seconds. When the aircraft had reached approximately 90 knots, someone, likely the captain, finally pushed the toga buttons, which would have activated the flight directors. But since the thrust should have been set by 60 knots and the outer throttle goes into a mode known as throttle hold at a speed of 84 knots, the correct takeoff thrust still wasn't set, and it's the job of the pilot monitoring, in this case the captain, to monitor that that is actually done. 2 seconds after the takeoff rotation, the thrust was finally adjusted to 88% N1 on both engines, and this serves to show that already from the very beginning of this flight, the pilots weren't following normal procedures and seemed to lack some fundamental understanding of the automatic systems of board their aircraft. The flight continued climbing towards the east, and the first officer eventually engaged autopilot B, which would stay engaged for the majority of this flight. Soon after their departure, the FMC updated its position based on the Moscow VOR, but that only updated the position on the navigation display. The IRS position was still not correct, and the drift of the IRS continued with a value of around 1 to 2 nautical miles per hour. The aircraft continued to climb and reached their cruise altitude of just under 30,000 feet or 9,100 meters at around 0330 in the morning. Now, all altitude references in Russian airspace are measured in meters, so I will continue using that going forward. Throughout the cruise portion of this flight, the outer throttle stayed connected, and it kept the thrust level staggered around 13 to 15 degrees because of the difference in thrust output between the two engines. This stagger meant that the N1 was equal on both engines, causing no side slip or problems for the autopilot to handle it, and as long as the criteria for the cruise thrust split monitoring system wasn't fulfilled, the outer throttle continued to function, and as far as we know, the flight continued throughout the cruise without any real problems. When the aircraft was about 110 nautical miles or 200 kilometers away from Perm Airport, the pilots started discussing which arrival and approach they were likely going to be flying. They were also discussing what the local QFE setting was, and by the way, this is another difference between flying in Russia and in the West. The Russians often use a pressure setting known as QFE for their altimeters, which, when used, will show the aircraft height above the landing airport instead of the altitude above the sea level, which we always use in the West. The first officer now tried to load the arrival and approach routing into the flight management computer, but they were not available from the FMC memory, so he had to program the waypoints himself, something he was having some huge problems with. He just didn't seem to understand the logic behind FMC programming and was asking the captain for a lot of help. This work took a lot longer than he had expected, and because of this it looks like the crew completely skipped doing an approach briefing and also didn't do the descent checklist. Now, from a crew resource management standpoint, this is a very serious omission, as the approach briefing not only confirms that everything is properly set up, but also sets out the plan for how the approach will be flown so that both pilots share a common understanding of it. It's also the time where we typically discuss upcoming threats like terrain or changes of runways and how we will deal with them, so skipping it is just not an option. The captain now called up the air traffic controller and requested to start the descent. The controller answered and cleared them to initially descend to 4,500 meters, which is about 14,000 feet, and to contact the approach controller when they passed 5,100 meters. As this new cleared altitude was set by the first officer in the mode control panel, he didn't make any call-outs and there was no cross-checks of the set altitude done by the captain, which is another major breach of procedure. These type of omissions, plus a general lack of communications regarding changes in autopilot modes, FMA changes and clearances, continued throughout the descent, and in fact none of the important safety barriers that have been put in place after so many other tragic accidents seem to have been used in this cockpit at all. On top of these procedural errors, the captain also made several strange minor mistakes, like confusing their call sign, referring to incorrect altitudes for pressurization checks, etc., which pointed to him not being at his absolute A game, even before the approach started. Now, what they did do during the descent was to trash talk the cabin crew and the air traffic controller for no apparent reason whatsoever, as well as discuss other non-operational subjects, breaking the rule of sterile cockpit as they did so. The autopilot modes used were LNAV and VNAV, which provided an idle descent and therefore no thrust asymmetry, but that will soon change. The captain would, for example, tell the first officer to take the radio, which is a pilot monitoring duty, indicating that he was instead taking controls, but he would then also do other tasks like turning on the engine NTIs, which is a pilot monitoring duty, all while sporadically making control inputs. Now, a foundational principle in how we fly the Boeing 737 is what we call adherence to areas of responsibility. This means that certain tasks are always done by the pilot flying and others are done by the pilot monitoring. It's done like that to minimize confusion regarding who should do what and when, and it's extremely important in a two-pilot cockpit, but it clearly didn't happen here. Anyway, at time 04:49 and 30 seconds, the aircraft passed 5,100 meters, and the first officer, who apparently was doing both the pilot flying and the pilot monitoring duties at that point, reported this to the air traffic controller and was then told to contact the PERM approach controller on a new frequency. When the first officer checked in, he was told to continue the descent to 2,700 meters and then proceed via the Mendeleevo 4 Bravo arrival route. The first officer correctly read back the altitude clearance, but he then incorrectly read back the Mendeleevo 4 Alpha arrival, which was what he had prepared for in the flight management computer. The controller corrected him, and even though he now read back the correct clearance, this seemed to greatly confuse the first officer, who was not prepared for this change of plan. The new arrival route would require quite a bit of different maneuvering by the crew, bringing them in over the final for runway 03, then out to a locator beacon called the Papa X-ray, followed by a base turn towards the ILS for runway 21. The arrival route that the crew had prepared for was a much simpler direct routing towards a point called Sindra and then a turn towards the ILS, likely the one that they would normally get. Now, even though this arrival was significantly different, the crew did not do any kind of rebrief of it. It turns out that the reason for this slightly unusual arrival route was that a Lufthansa Airbus A319 was getting ready to depart from Perm and had requested runway 03 for departure due to a slight tailwind on the landing runway, runway 21. This new arrival route would create some extra separation between the departing traffic and the landing of flight 821, but there was no intention from the controllers to actually change the landing runway. The crew now started discussing how to actually fly this new route, and the first officer asked, how is Bravo different? This discussion was interrupted by a cabin crew member entering the cockpit, reminding the pilots that the fasten seatbelt sign had not yet been switched on. The captain responded that it was too early for that, when in fact it was definitely time to put that on. If another crew member reminds you about something that you have forgot, then you should always thank them and just do it. It doesn't matter who is right, it's what is right that's important. But instead of doing that, the captain now apparently thought that it would be a great idea to ask the cabin crew member for a cup of tea instead, in the middle of this complicated change of navigation and during descent, and when she was likely busy with her own procedures, and that's likely why she had reminded them about the seatbelt sign in the first place. Now, it's unclear if he ever got that tea, but again, this is a very strange thing to prioritize. At time 04:50 and 37 seconds, the controller came in and gave the crew an explanation for the change of arrival route. He said, Aeroflot 821, expect approach via automarker, and for your information, aircraft lining up for departure, wind not suitable for it, heading 212. This was a quite convoluted way of explaining the reason to the crew, and it indeed seemed to just further confuse them. The first officer now asked, so what are we going to do? Present course? And the captain, who had taken over the radio again, called up the controller and asked him about the wind. And he was told that there was a tailwind of 5.7 meters per second, or about 11 knots for runway 21. He responded that this was an acceptable tailwind for them, and the controller came back again and said that he had only given them the reason for the Lufthansa crew changing takeoff course. To conclude this exchange, the captain then finally asked, which course? And the controller responded, to the automarker, Papa X-ray. The captain read back, course to the automarker, Roger, but without clarifying if this was via the previously cleared arrival route or just directly to it. As you can see from these exchanges, quite a bit of confusion now seemed to have started to build up in the cockpit, and the way that the controller interacted with them certainly didn't help. Because of the discussion regarding the tailwind, it seems like the pilots now, especially the first officer, started thinking that they were actually cleared into a pattern for a landing on runway 03 instead of runway 21. He actually said that multiple times during the next few minutes, but none of the pilots bothered to actually ask the controller to confirm which runway they could expect, which would be the logical thing to do. From this point onwards, the captain started sounding very annoyed, and later speech analysis of the voice recorder showed that he was likely experiencing increasing stress levels as the flight now continued. The confusion regarding the landing runway just continued in the cockpit as they were getting closer and closer to the airport. And when the first officer asked the captain about it, he was just told that the controller will tell us. Eventually, however, it seems like the captain decided that it was likely going to be the ILS for runway 21 after all, and he inserted that into the FMC, but without communicating that fact to his first officer. The aircraft now descended through 10,000 feet with no pressurization check done by the captain, which is a further lapse in his standard operating procedures. Now, remember that IRS drift that I talked about earlier? Well, as the aircraft was getting closer to their destination, that drift had now increased to about 4.5 kilometers, meaning that the position of the aircraft depicted on their navigation display showed a position 4.5 kilometers more to the northeast than their actual position was. This will soon become very important. Now, the fact that the aircraft wasn't actually tracking towards their cleared waypoint should, of course, have been noticed by the crew by cross-checking the NDB needle. It would have showed that it was pointing somewhere else. But the frequency for the Papa X-ray had not been actually tuned in, likely because the approach briefing hadn't been completed, and therefore the NDB needle didn't really point to anything. The approach controller could of course see on his radar screen that the aircraft wasn't routing towards the Papa X-ray beacon as he had cleared them to do, but he didn't mind that much because it actually provided more separation to the departing Airbus than he had originally planned. The aircraft was now clear to continue to descend to 2,700 meters, or about 8,000 feet, and then await further clearance. The pilots were using level change for the descent, meaning that the thrust levels remained in idle, but when they reached the cleared altitude, the autothrottle started moving the thrust levels forward to maintain the speed. And as that happened, they again moved to different angles to maintain the same thrust output. Since the autothrottle couldn't do this compensation immediately, some thrust asymmetry was introduced and the control wheel started displacing to counteract it. This was, however, not noticed by the pilots, who were too busy discussing which direction the next turn was going to be. The captain thought that they were going to receive a left turn to base to directly intercept the ILS, whilst the first officer predicted that there would be a right turn for a downwind leg, something that would be necessary because they were still way too high to start the ILS approach. This discussion was then cut short by the controller, calling them to descend to 2,100 meters and then turn right towards the back course, meaning the opposite course to the landing runway. But unfortunately, he still didn't clarify which the landing runway was actually going to be. He just assumed that the crew knew this. The captain was sure that the controller was referring to runway 21, which was actually correct, but the first officer still thought that it was going to be a right turn for runway 03. Now, at this point, I just want to point out how utterly absurd it was that they were now overhead the runway, still debating which runway they were going to land at. But this was just the beginning. Since the flight management computer most likely had been programmed to proceed direct to the threshold point for runway 21 after the Papa X-ray and the aircraft was still flying in LNAV, it meant that it had already started the right turn, even before the controller cleared the crew to do so. Now, however, since the aircraft was unable to reach this threshold point with the speed that they were flying, around 220 knots at the time, it instead started turning left to get back to this point. And that completely confused the first officer, who called out, "Where is it going? I don't understand where it's going." Now, that's never a good thing to hear from a pilot. The captain told the first officer to engage heading select instead, which was a good call at this point. He also told him to turn right to heading 030 degrees for downwind as they continued to descend. At time 04:59 and 23 seconds, the aircraft started leveling off at 2,100 meters. This again caused the thrust levels to start moving forward to try to match the thrust demand, and as that happened, a significant thrust asymmetry again started developing. But since the aircraft was in a right turn and the right engine was producing more thrust, it created a side slip with a left roll component, meaning that the autopilot had to input even more right aileron to continue the turn. Now, this caused the spoilers to raise above a certain threshold value of the right wing, finally satisfying the requirements for the cruise thrust split monitoring system to activate and then turn off the autothrottle. When that happened, an autothrottle warning light came on, which was acknowledged by both pilots. The captain now told the first officer to keep flying with manual thrust, and this now made things considerably more complicated. Because since he was now moving the thrust levels manually, the first officer moved them in synchronization, which, due to the persisting failure of the thrust trimming, meant that the engines would now start producing considerable asymmetric thrust from this point onwards. None of the pilots monitored the actual N1 on the engine instruments, and because they didn't do that, the first officer never diagnosed the asymmetric thrust and therefore also didn't apply any opposite rudder to counteract it. What this in turn meant was that the autopilot had to move the control wheel to try and keep the aircraft on the correct course, and that actually worked for a while, but only as long as the autopilot was actually engaged. 45 seconds after 5 o'clock in the morning, the aircraft had finally established itself on the downwind course and was now instructed to descend to 600 meters, which was the ILS intercept altitude, about 2,000 feet. The captain finally asked, "Confirm for an ILS approach," which the controller did, and since runway 21 was the only runway with an ILS approach in Perm, it meant that finally the crew knew which runway they were going to land on a full 12 minutes after this first doubt had started to occur. The pitch mode level change was now selected in order to get the aircraft to descend, together with flaps 1, without any callouts, but the thrust levels were not moved to idle. Because the thrust had been left at a rather high value by the first officer, the speed now started to accelerate towards 232 knots, and in level change the aircraft will not descend unless the thrust is reduced. Level change is a pitch mode created primarily to keep the selected speed, and if the thrust is enough to maintain the speed, nothing will actually happen. When the auto throttle is engaged, this is never a problem, because with level change selected, it will set either idle thrust for descent or climb thrust for climb, but with manual thrust, you need to look after that yourself. The captain must have seen the high speed, so he commanded the first officer to start using speed brake and to reduce the speed to 190 knots. The thrust was now reduced back to idle, but again, in level change, the aircraft will prioritize the speed first. So in this case, it was decelerating the aircraft down to the new commanded speed without starting any real descent until that was accomplished. This really seemed to confuse the first officer, who asked several times why isn't it descending, as they kept deselecting more flaps and also simultaneously reduced the speed further. The controller now called the aircraft up and told them that they were about 16 kilometers away from the airport, but still at 1800 meters, and asked them if they were actually descending. This made the captain absolutely furious, and he shouted out, "How low must we descend? How low must we descend?" To which the first officer replied, 600 meters, and the captain then immediately called this back out to the controller, who obviously knew this, as he was the one who had cleared them to descend to that altitude. From this point onwards, the captain started acting truly unhinged, and the analysis of his voice indicated some very high stress levels. He now started asking the controller if they could begin the right turn to intercept the ILS, which was not appropriate from the position that they were in, since they were still at 1700 meters or 5200 feet, more than twice as high as they should be in order to capture the glide slope from that distance. They had just descended through the transition level, where the local pressure must be set on the altimeters, so the controller now asked the crew to confirm that this had been done. And the captain did confirm that they had, before he again asked to turn towards the final. Setting QFE was the trigger to go through the approach checklist, but that was never done either. And in fact, the QFE pressure setting was only set on the first officer's altimeter, not on the captain's, something that the approach checklist was actually designed to pick up. When the captain now asked to turn inbound for a third time, the controller finally caved and cleared them to turn base when ready. He also informed them that they were at a distance of 20 kilometers for the runway, or about 10.8 nautical miles, clearly indicating that he thought that it was still too high to start the approach. So why did the captain want to turn inbound this early? Well, remember that IRS drift that we talked about before? The captain was likely looking down on his navigation display, which showed a position about 4.5 kilometers more to the northeast than they were actually at. Now, even with that error in, they would still have been quite high, but not as desperately high as they now were. The turn towards the final was started at time 0504 and 15 seconds, and since they were more than twice as high as they should be, the captain decided to also lower the landing gear and extend the flaps to 15 in order to increase the drag. But since he also told the first officer to reduce the speed, the aircraft again initially reduced the descent rate to achieve this lower speed, making them even higher above the profile. The aircraft rolled out on a heading of 160 degrees to intercept the ILS localizer, which would have caused them to capture the localizer about 9 kilometers away from the runway, instead of the stipulated 12.6 kilometer, making it completely impossible to follow the glide, which would be well below them. But in the cockpit, it still looked like they would intercept at around 14 kilometers out. It's likely that the first officer at this point saw the problem, because the ILS pointers would have now been visible on his EADI, with the glide slopes showing up full deflection below them. He now asked for flap 30, but the captain didn't respond, because he was now talking to the approach controller, who was transferring them over to the ground controller. So the first officer had to call 2 more times before finally the captain answered. And what he answered was truly bone-chilling. He said, "Do everything yourself. Flaps, thrust, MCP changes, everything." Now, To say that to a less experienced colleague in the middle of a very dynamic, complicated and accelerating situation is among the worst examples of CRM that I have ever come across. In any case, flaps 30 was finally selected, likely by the first officer himself, meaning that the aircraft was now fully configured with gear down and landing flaps as it reached the cleared altitude of 600 meters. Now, things will start happening very quickly. Because the autopilot was still engaged and the aircraft was now leveling off, the speed started reducing rapidly from 150 knots down to below 130, which was the minimum for flaps 30. Since the aircraft was in landing configuration, it was now producing a lot of drag, and some of the negative feedback that the first officer had received during his type rating was that he wasn't very good at predicting how much thrust he needed when extending flaps, and tended to just react to the speed changes with erratic thrust level movements. And that's exactly what now happened, and when he started inputting more thrust, the thrust asymmetry again started kicking in, which was his other documented weakness. The autopilot, who was still engaged, started inputting aileron to try and counteract the side slip, but since the speed was now significantly lower, more aileron was needed, and the autopilot quickly came up against its limit of 25 degrees of control wheel input. Since it couldn't do more after that, the aircraft now started slowly rolling to the left with a rate of around 2 degrees per second. This was not initially noticed by the first officer, who was fixated on the speed control, and neither by the captain, who was talking to the ground controller about weather conditions and obviously not monitoring the flying at all. At time 05:06 and 44 seconds, the roll mode LNAV was selected, likely by mistake, and then quickly changed over to Vorlock. 4 seconds later, the left roll had reached 32 degrees, and now the first officer must have looked down and realized it. As a reaction, he immediately applied right aileron, but since the autopilot was still engaged, this caused it to go from Vorlock to control wheel steering roll, which is a lower mode of automation, basically working like a servo to the pilot's inputs. The first officer probably wasn't very familiar with control wheel steering, and since he continued to input on the controls, he also now inadvertently pushed the yoke forward, causing control wheel steering pitch to activate as well. So at that point, he was now flying the aircraft with manual thrust control in landing configuration with control wheel steering, desperately trying to understand what was happening. He initially managed to get the roll under control, but since he also added a lot of thrust to regain the speed, the undermounted engine started pitching the nose of the aircraft up, causing a climb. 20 seconds later, he likely inadvertently also pushed the electric trim button switch on his yoke, causing the autopilot to disengage. The high thrust had now caused the speed to increase to 160 knots, and when the first officer realized this, he immediately reduced the thrust. But the aircraft continued to climb, which meant that the speed now quickly washed off, reducing back to 110 knots, 20 knots below the minimum speed for flap 30. So what was the captain doing then? Well, he hadn't monitored the attitude of the aircraft at all. Instead, he now reactivated the Vorlock mode, and since the aircraft was actually on the center line, the flight director captured it. He then looked down, realized the low speed and shouted "Increase!", which the overstressed first officer responded to by setting almost full thrust, again causing a pitch up of the aircraft. They had now climbed to 900 meters. That's more than 300 meters higher than they should be, and the controller could obviously see this. He now asked the pilots if they were actually climbing. This prompted the captain to tell the first officer to look at the vertical speed indicator, and then, after a short pause, confirmed to the controller that they were indeed climbing. The controller saw that there was absolutely no way for the crew to land from the position that they were now in, and told them to turn right heading 360 degrees and descend to 600 meters, effectively ending the approach. But the captain did not agree with this. He instead spent the next minute trying to convince the controller to let them continue to land without doing a second approach, which must be seen as just pure lunacy at this point. And even worse, as he was having this lengthy discussion with the controller, he made several abrupt control inputs to the right, causing the bank to first go to 17 degrees right and then to 50 degrees right a few seconds later, triggering a bank angle warning. Remember, the first officer was still trying to fly manually as this was happening. Even the controller thought that the discussion he was having with the captain was a bit strange, and he actually asked, "Is everything all right with the crew?" To which the captain responded, "Affirm." After the bank angle warning, the first officer cried out, "Where are you? What are you doing?" And then miraculously actually managed to get the aircraft back from that steep right bank. But whilst doing so, the aircraft had again pitched up to 15 degrees, which caused another rapid climb and the speed to again drop back to 113 knots. From time 0508 and 25 seconds, the thrust levels were again moved forward, leading to new thrust asymmetry, and this initiated a left roll with around 1 degree per second. During the coming 25 seconds, it looks like the first officer just gave up, because there was no inputs in either pitch, roll or thrust, and when the bank again reached 30 degrees left, with the speed decreasing, the first officer just called out, take it! The captain was apparently surprised by this, which he really shouldn't have been given the roller coaster that the aircraft had been on for several minutes at this point. He responded, "Take what? I can't do it either." And then abruptly took the controls anyway and started inputting aileron to the left, the same direction that they were already rolling, instantly increasing the bank angle to 76 degrees. The first officer saw this happening and called out, "On the contrary, in the opposite direction," which seemed to help momentarily, but the captain then continued to make several abrupt inputs in both directions. At time 0509 and 14 seconds, the captain made his final mistake in this dreadful flight by giving almost full left input on his joke. It is very likely that the Western-style EADI, especially with the V-bar flight director, played a role in the captain's final loss of situational awareness. The V-bar flight director would have, in this case, been situated below the horizon and showing a right bank, which is what he needed to do in order to recover. But in his confused state, the look of the V-bar likely reminded him of the aircraft symbol in his earlier aircraft, which would have meant the complete opposite thing, which caused him to roll in the wrong direction. The result of this was that the aircraft now made an almost full barrel roll, still in landing configuration, causing a pitch-down angle of 65 degrees, from which it was impossible to recover. The aircraft impacted the ground at a speed of 250 knots in a 30-degree left bank turn, causing the immediate loss of all 88 people on board. As it crashed, the aircraft impacted a part of the Trans-Siberian Railway, which was severely damaged, but luckily no one on the ground was hurt. Since the accident happened close to the airport, the aircraft was quickly found by both airport rescue personnel and local firefighters, but there wasn't much they could do except securing the area and start looking for the black boxes. These were eventually found, but severely damaged, and when the investigators finally managed to access them, they were shocked by what they found. The non-adherence to standard operating procedures, poor technical knowledge and almost non-existent CRM between the pilots had led them to completely lose situational awareness and ultimately the control of the aircraft. But that wasn't even the worst part. It was discovered that one of the passengers had apparently sent an SMS to a friend in the United Kingdom just minutes before the flight took off. The message said that the sender was very scared because the captain had just made a PA and he sounded totally drunk. Even though the first test of the captain's body had come back negative for alcohol, this caused another new test to be made using more detailed techniques, and that confirmed that the captain had between 0.5 and 1 promille alcohol in his blood when the accident happened, and that would have meant a substantially higher alcohol level when they took off, which would have accounted for that blurry, slurry PA. This and the possible accumulated fatigue likely explained why the captain's speech pattern indicated heightened stress levels from an early point in the approach, and why he ultimately also lost control. The investigation completely hammered the Russian aviation authorities, the airline, the maintenance organization, and the air traffic controllers that were on duty that night. In total, 40 different safety recommendations were issued, which in some cases were as sweeping as eliminate other shortcomings revealed in the course of the investigation. But some of them included implement better pilot training, including upset prevention and recovery training, verify English proficiency, and extra training and checking of pilots going from old Soviet to Western aircraft. This is the first time that I have come across a report where the whole system seems to have failed, from the initial training through the maintenance, individual responsibility, rules and regulations, and the aircraft itself. But I can honestly say that this is likely the exception that proves the rule. Airlines like this just shouldn't exist, and you can always check the EU blacklist of dangerous airlines before booking tickets with any airline that you haven't heard about. I will link to the blacklist in the description below. Now, please consider checking out the deal my sponsor offered in this video. It really supports the channel, and check out this video next. It'll put you in a much better mood. Have an absolutely fantastic day, and I'll see you next time. Bye-bye.